Example 27, show that the relationship between Froude numbers before and after the jump and vice versa is given by, for the Froude number after the jump, 2 square root of 2 Froude number 1 before the jump over quantity square root of 1 plus 8 fr1 square minus 1 raised to 3 halves, and vice versa, fr1 is 2 square root of 2 fr2 quantity square root of 1 plus 8 fr2 square minus 1 raised to 3 halves. So only one is to be shown, then it looks the same. So we begin by the hydraulic jump formula for rectangular channels. This is only for rectangular channels. Small q square over g equals dep1 dep2 over 2 quantity dep1 plus dep2 square. Then distribute. So 2q square over g equals dep1 square dep2 plus dep1 dep2 square. Rearranging to form a quadratic equation. So dep1 dep2 square plus dep1 square dep2 minus 2q square over g equals 0. So our variable here is dep2. So this is capital A of the quadratic equation, dep1. Then b is d1 square. Then this is the whole thing is c. So dep2 is equal to negative of b, so negative of dep1 square, then plus minus square root of dep1 square, so dep1 square square, so the dep1 to the fourth minus 4a, a is dep1, c is negative 2q square over g over 2a, so 2 times dep1. So simplifying and rearranging, because the value of the radical is definitely greater than negative dep1 square, so we write this first, then minus dep1 square. So we use plus, of course, because this is greater than negative dep1 square. So dep2 is equal to square root of dep1 to the fourth plus 8 dep1 q square over g, then minus dep1 square over 2 dep1. So we use plus for the radical, then that's minus. So simplifying further, and take note that q is dep1 v1 equals dep2 v sub 2, so that q square over q square is dep1 square v1 square, and it is also dep2 square v2 square. So dep2 therefore is equal to square root of dep1 square 8d1 q square, which is dep1 square v1 square from here, over g, then minus dep1 square all over 2 dep1. So this is dep1 to the fourth plus 8 dep1 cube. Let's make this dep1 to the fourth, so we have to divide dep1 here so that we can factor out dep1 to the fourth inside the radical, and of course the square root of that is dep1 square, so that we can factor out dep1 square also, so this becomes minus 1. So dep2 is dep1 square root of 1 plus 8 v1 square over dep1 g. So I mentioned that we have to make this dep1 to the fourth, originate dep1 cube. So dep1 to the fourth over dep1, that's why we have dep1 here. And minus 1 because we factored out dep1 square over 2 this d sub 1. So fr1 equals v1 over square root of g d1, and squaring fr1 square equals v1 square over g d1, so that v1 square over d1 is simply v1 square over g d1 is simply fr1 square into this radical here. So dep2 equals dep1 from here, because we can cancel dep1 also, dep1 square over d1. So dep1 over 2, then square root of 1 plus 8, we haven't yet replaced v1 square over gd1 by fr1 minus 1. So therefore replacing v1 square over dep1g by fr1 square. So the formula for dep2 is after the jump is equal to dep1 square root of 1 plus 8 fr1 square minus 1 all over 2. So this is the formula for the depth after the jump. So it is a formula in terms of fr1 or Froude number 1 in the before the jump. So let's continue. So v2 square over g fr2 square is equal to v1 square over g fr1 square because this is depth 2 from here. So v2 square over gfr2 if we begin with fr2 just like this because fr1 square is v1 square over d1 square dep1 is v1 square over g fr1 square. So therefore dep sub 2 square, if we square dep sub 2 square is v2 square over g fr2 square. If we define it here, fr2 square equals v2 square over gd2. So d sub 2 is equal to v2 square over g fr2 square. So that's why depth 2, this is depth 2, v2 square over g fr2 square. This is fr, this is depth 1 from that formula. And depth 1 here is v1 square over g fr1 square. So don't be confused with that. Then we just copy this. So fr2 therefore is equal to, if we solve for fr2, it is 2 times quantity v2 square over v1 square after we cancel g. Then over, no, if we solve for fr2 square from here, so it is equal to quantity v2 square over v1 square times fr1 square. This is it, times 2. So 2 fr1 square, then quantity v2 square over v1 square. So that's fr2 square divided by this quantity here, square root of 1 plus 8 fr1 square minus 1. So v2 square over v1 square from this v2 over v1 is dep1 over dep2 quantity square. So v2 square over v1 square is also d1 square over dep2 square from this relation, v2 over v1, then square it equals d1 square over d2 square. That's it. Then it is also equal to d1 square, which we just copy over d2 square. And d2 square is from this equation here. So if we square this, we have d1 square quantity square root of 1 plus 8 fr1 square minus 1 square, then over 4. So put 4 in the numerator. So v2 square over v1 square equals d1 square over d sub 2 square equals 4 after we cancel d1 square over quantity square root of 1 plus 8 fr1 square minus 1 quantity square. So fr2 square, therefore, from this equation here is equal to 2 fr1 square times v2 square over v1 square, which is equal to this. So we just copy it. Then divided by this denominator. Square root of 1 plus 8 fr1 square minus 1. So take note that this and this are like terms. So we have fr2 square equals 8 fr1 square all over quantity square root of 1 plus 8 fr1 square minus 1 cube. So fr2 square equals 8 fr1 square all over quantity 1 plus 8 fr1 square minus 1 cube, because this is square and this is raised to 1. Finally, fr2 is square root of, by extracting square root of 8 is 2 square root of 2 fr1 over quantity square root of 1 plus 8 fr1 square minus 1 to the 3 halves. Similarly, fr1 is 2 square root of 2 fr2 all over quantity square root of 1 plus fr2 square minus 1 to the 3 halves. So that's it. That's the proof. So the formula is difficult to memorize, but if you understood the derivation and you can derive this by your own, then it's easy to remember also. So take note of depth 2 and this Froude number before and after the jump relationship.